All right, great. So I'll take cybersecurity as a topic, but I'll look at it broadly, systems, networks, and all the software that runs in it, which covers a large part of what we consider computer science. I won't try to tackle hardware or theory, and I'll leave AI to Yolanda, though I love using a lot of the AI techniques, so thank you very much. Please provide more great things for us to use. So let's see if this is perfect. Okay, so I noticed Yolanda had a number of these strategic roadmaps, and I think that was great. I asked some friends, they said, oh yeah, there's bazillions of them. So this one's nice. This is from NITRD, an organization which, by the way, you can go and brief, and we have briefed them from time to time on things like deter, and they're actually sitting there every 5 years or a little more frequently setting an agenda or trying to summarize what the coordination is across all the federal agencies, where they think the future is going. And then what's even nicer is they sometimes take a listing of all the programs they're doing, and they put them on that roadmap and say, well, here's where they are. These programs address these issues. And there's little subtle things, like they scored this one according to some categories. So there's deterring attacks, protecting systems, detecting attacks, or adapting, or wait, in the latest version, responding to changes, because there's a little footnote. Well, responding is broader than adapt, and so they update their thinking. So there's both the language and what they do. But the key thing is you can bring ideas into this process. It's not just some people that we don't know up there on a mountain come up with these ideas. These people are colleagues of ours, or us ourselves when we're doing hard thinking. So we bring ideas in, and then we see what programs come out, and we can think about that. So let's see if I go forward a little bit. Okay, so non-controversial future directions. We've all worked with a slew of funding agencies. I like DARPA. I've got a lot of funding from them, but some of the other ones on the list also have funded us pretty nicely. And they have programs that cover all sorts of cybersecurity topics, which I'll say a little bit more on in another slide. NSF SATC is the largest NSF size program. And an interesting conversation, I think of security as like, well, there's maybe 10 areas of security. So I was talking to one of the program officers, and no, there's like 40 areas that they recognize, because they've added in all these interdisciplinaries that include, technology and humans. And so the breadth of what is cybersecurity has expanded as computers have overrun everything else. Because what could go wrong with connecting everything we have to the internet? Nothing, right? And so that's what we do, and then we discovered, well, a few things could go wrong. And so that's creating problems. We always have to consider the humans and the technology jointly now. And there's a lot of questions about scientific rigor, you'll see. Repeatability, reproducibility, blah, blah, blah. What they're really saying is, do the results that you get from your research, are they durable? Do they actually hold up when you take them to different places, when other people try them out? So systematic evaluation requires methodology, tools, techniques, things I've worked on a lot. We've worked on a lot at ISI on test beds, and also on the idea that there's research infrastructure that goes beyond that. But maybe one point that I want to make is, if you sit on an NSF panel evaluating these proposals, what they get excited about is not that you're just going to build the latest gadget or something, but you're also going to do something in its evaluation or in the methodology follow that results in a scientific leave behind that's good for others. So it's not just that you built a secure X, but they also see the value. And in fact, I think it's rare. They see there's some corpus or technique or something that can be shared that helps advance the state of the scientific community in terms of figuring out whether other things also work. And so there's that idea shouldn't ever be missed, that you're doing something and then you're figuring out how to evaluate its scientific contribution, what you've done, but in a way that others can use too. Okay, oops, let's not get that slide right here. Okay, so I'm going to hit best way to predict the future is to invent it. I'm going to just talk about 3 programs that two come up, one maybe is in process, really quickly. So assured micro patching. We have Eric Klein and some colleagues have a proposal in. This is a great program idea, but it's how this program came to be that's interesting. So Mike Walker was a program manager at DARPA, did some successful things 5 years ago. but didn't quite launch this program. And the idea was, how do you deal with the fact that our most critical systems often don't get patched? Because when you patch a system against a security vulnerability, that could change the system, requiring you to take a lengthy retest, which might take a year, or might, if you're in the DoD, take like 10 years to get things out there again. And so we have all this embedded legacy stuff out there that's subject to attack. So what's interesting about the DARPA AMP program, and what maybe makes the idea novel, was Sergey Bradis, the program manager, recognized there are patches to known code out there, and there's variants of that code that have been basically built into everything in our embedded world. And if we can patch quickly those embedded systems, which are variants of software we know, and make sure it doesn't interfere, then we can radically reduce the time to get that secure patch out there in the world. And so the takeaway is, the idea is make it timely, to do something we've wanted to do for a long time. We just didn't know how to structure a program to do it. DARPA Ops 5G, where 5G is coming, open systems for 5G would greatly allow us to accelerate how quickly we can do things. Programmable systems would let us be much more flexible. But we really want the 5G systems to be secure. So this is a program which many of us have worked on programmable networks in some form for over 20 years. But the key thing is now, make it happen. And the motivation is, we want this to be open, transparent, secure, so everyone who uses the software can tailor what they get, can see that it's going to be secure. And there's a leverage issue here. A very small amount of secure software we add now as researchers can have a huge impact in a large world. And so one of the things we always think about now is, we live in an industry where we as researchers can do 0.1% of what industry can do. So we're always looking for what's a small piece that we can make that changes something with a lot of amplification. And then the last thing, privacy of smartphones. I could say humans using smartphones, but I'll argue the smartphones are the dominant species. The Homo sapiens just carry them around. But if you haven't noticed, right, there's been some press. Washington Post had a nice article on what college students are how they're being monitored by their universities. The data set analysis from the New York Times. Basically, everything about you can be captured by the ad tech coming off your phones. And with a little bit of analysis, it reveals almost everything about your pattern of life, what you're doing. So there's a lack of balance of interest between the commercial entities that want to advertise to you and you, the individuals who care about the societal impacts. As we see technology becomes pervasive, many of our research projects and ideas are going to be about, how do we restore balance between some individuals, what they're doing, and what society needs. And the last thing, well, on to questions, but that is a crazy idea. There's a cuttlefish with 3D glasses, and why, if you saw this, it actually makes sense. They're studying stereographic behavior in cuttlefish. So there's nothing wrong with building the crazy thing you need to do the research.